Hello, hello. Hello, everyone. Hello, hello. Welcome, welcome. Today we're going to be going over the Swarm's 8.0.0 update, which is the latest Swarm's update. It's one of the biggest updates that we have ever done. And I would like to go over some of the latest updates with you all because they're very, very exciting. Um, so, yeah, uh, let's get started. Um, Sorry for that. Yeah. So this is the Swarm's 8.0.0 updates. We basically, uh, for the past month, we've done a lot of updates, including adding entirely new multi-agent architectures. We have solved a lot of bugs, dozens of bugs. We have made lots of improvements to existing multi-agent structures, all of which you're going to be seeing code demos for today. So very very exciting, and yeah, let's get into it. So first, what is Swarms? Who are we? Our fundamental mission is to accelerate the transition to an agentic economy by building reliable production grade agentic infrastructure. Our Python framework is our flagship product, and through it, we provide enterprises and startups with multi agent architectures, multi agent memory systems, optimized runtimes, and much, much more. If you would like to learn more, you can go to our website, swarms.ai, and check out some of our frameworks and developer tools there. Um, and yeah, that's a little bit more about us. Now to get started, like to actually use the framework, we can do this in a couple of ways. So we could do this with pip install dash capital U swarms. You just open up your terminal, you get swarms, and then you get your latest updates here. And that's all you have to do. If you use UV, you can use UV pip install swarms. I don't know if this is going to work for me. Yeah, it's not going to work for me. But if you use UV, you can also use swarms on UV. UV is very popular now. So um, actually, I don't think it works. Yeah, I see. Yeah, to use UV, you need to do UV BNB. Yeah. But yeah, that's how you get started. That's how you install swarms, and we're going to be going over some code demos pretty soon. So yeah, version 8 8.0.0 overview. So we in this update we introduce a couple of new architectures. Graph workflow is one. Heavy swarm is another one. Heavy swarm is pretty interesting because it basically mimics how Grok 4 Heavy works. So if you've seen Grok 4 Heavy, then you know how Heavy Swarm will work. It's basically the same thing, except that you could basically use any sort of LLM that you want. You can use GPT-4, you can use Gemini, you can use any model that you would want. So yeah, it's very very cool. And then we have a bunch of other specialized architectures for debates, philosophy discussions, and a vast array of other activities as well. So that'll be very interesting as well to demo. We also have cron jobs. So cron jobs are very interesting because they basically enable you to run an agent every in a period or interval. So you could run an agent maybe every 10 seconds. You could fetch a stock maybe every 10 seconds. You could run an agent every hour or every day or every 2 days or every 5 days, etc. So it's very customizable, and cron jobs enable you to basically run the agents in like frequent intervals. So yeah, that's kind of like an overview of the new features. We also have a vast array of improvements to existing features, such as we have a new dashboard for the concurrent workflow. The concurrent workflow is essentially like it is a mechanism in which enables you to run multiple agents at the same time. So you could run like maybe 10, 20, 30, 40 agents all at the same time. And the dashboard makes it beautiful. So you're going to be seeing that pretty soon. And yeah, we updated our MCP infrastructure as well. So in the backend, we have updated all of the like streamable HTTP stuff because before MCP is kind of like not really advocating for SSE events anymore. So we were mostly using SSE events. Now we're using streamable HTTP. So that's a new update as well. The next improvement is the Swarm router update. So the Swarm router update, we have significantly improved the speed with Swarm router. We have introduced like this cache, and it makes it much faster. We also made improvements to self-consistency agents. We made a lots of improvements to the hierarchical swarm, which is very popular and very widely used. And we also have introduced new documentation and new product updates. Yeah, that's kind of like a overview of the framework as of now. So yeah, let's get into it. The graph workflow. So the graph workflow is essentially like it's an all new structure that enables you to build custom graphs of agents. We call it the LangGraph killer. So you could basically orchestrate agents in many various different fashions. You could have edges and nodes and connect these nodes with other agents. It's much faster than any existing or alternative solution, as the graph is embedded in raw network-X, which is a graph library in Python. And we're also now trying to build the infrastructure for RustWorks, which is a graph library in Python that is significantly faster than every other graph library. So pretty soon it's going to be getting even more faster. But some of the like interesting features that it has is that it enables you to process agents in parallel. So if you have like different nodes that are connected to agents in a specific fashion, it'll automatically concurrently execute those agents. We also have embedded visualizations. So you can use GraphViz, which is a Python framework to visualize the graphs and makes it very easy to visualize your graphs. We have also like essentially built this compilation engine, which reduces execution time and caches the graph architecture for the next run if you're running it again. And we have also significantly made it very, very memory efficient to run as well. We've also integrated scalable design patterns such as fan in, fan out, fan in, and mesh topologies to support complex multi-agent workflows. And we have also added in persistence, which is the ability to export the entire graph as a JSON with audit trails and the entire conversation history. And so, yeah, that's kind of like an overview of the graph workflow. I'll be showing you some code examples now. So, yeah, this is basically how it looks. We're not showing like how the agents are built here, but this is the syntax or how it looks like to run the actual graph workflow with the syntax here. So you do workflow equals graph workflow. Then you do workflow.add node, workflow.add node, and then agent 2, and then you could define relationships. So agent 1 here in this code is going to talk to agent 2. Then you could also print to JSON, which will basically just print a JSON, or you could visualize the code itself. And now I will show you the code right now. Let's see. So this is the examples folder with graph workflow. We have a couple of examples here that you could check out. I'm trying to find one. This is one with a lot of agents. Yeah. Let's see this one. Yeah. This is a pretty simple version. Nice. Let me just make this bigger now. All right, cool. So basically, you import from Swarm's import agents, and then you then import the graph workflow. You could also make this simpler. Um, and yeah, you can import a prompt as well. Here we're importing a prompt. Here we're going to define two agents that we're going to put into the graph workflow. So they're pretty simple agents. You just give them a name, give them a model, and yeah, these are pretty simple agents just for illustration purposes. Yeah, so you build the agents, you give them names, models, max loops, etc. Then here you initialize the graph workflow. You could add the node, which is the two agents. You add two nodes, and then you could define how the agents communicate. Now, we're also going to do the visualization. So we do something like workflow.visualize. We could also choose what type of image you want to get. You can get PNG or JPEG, and yeah, you can get SVG or I don't know if you can get PDF. We'll have to test that, but yeah. Here's the JSON as well, just workflow to JSON, and this is the cache, or not the cache. Let's see if we could put the compile. Yeah. Yeah, so this is the compilation feature that I was talking about. So it basically pre-computes extensive operations for faster executions. And we should call this after we build the structure so that the results are cached to avoid recompilation in multi-loop scenarios. Yeah. So in the graph workflow, we could also give the graph workflow name. So here we have research agent. So we're going to call it research workflow. And then we could also give it a description. And then we could also add auto compile, which is another feature that will basically save us memory. And then we can format the code to make it look nice. Yes. And yeah, that's kind of like some cool features to know. We could visualize it. We can compile it. We can save it to JSON, etc. Now, to actually run the workflow, this is what you could do. You do a workflow after you initialize it. You do workflow.run. What are the best arbitrage trading strategies for altcoins, etc.? And so this run method here has the entry point into the actual graph. Whatever you put here will kick off the graph in the starting point, and then the graph will execute as you have designed it. So yeah, if we execute the script now, we can see how it will function. And it's going to create an image of the results as well. You see, there's the image. That's the JSON. It's pretty big, but it has everything. It has like all the information that you would need. It has, yeah, it's like full persistence. So it enables you to just like load the graph and then pick up the graph so that, it can be run again. So now the agents are actually working. I don't know if y'all can see this. Is restating the task, you've asked for the best arbitrage strategies, trading strategies for altcoins, along with the research papers and articles on the topic. Yes, that's the first agent, which we saw just now. And then the second agent ran and says the second agent says, thank you, research agent 1, for your clear and thorough breakdown of altcoin arbitrage trading strategies, as well as the curated list of research papers. Your response follows a logical structure, covers the main strategy types, and provides repeatable sources. I will proceed to verify your findings using the 3C protocol and then build upon your contribution. So the agents here, an outstanding problem of multi-agent collaboration is that the agents sometimes will not acknowledge other people's work. And we have fundamentally solved this problem. So as you can see here, the agents are basically they're acknowledging each other's work and then they're building on each other's work, which was extremely difficult to do in production. So um, yeah, that's kind of like an overview of how it works. And to adapt this to whatever application or use case you're doing, you would give the agents a better name, better system prompts. You would specialize them, give them data, integrate RAG into them, and etc. These are just very simple agents for the purpose of teaching how the graph workflow works. Um, yeah, yeah. So that's how it works. It's very simple. And we're gonna stop that now. If you want to learn more about the graph workflow, I would highly recommend that you go to our documentation, such as workflows, and you go to graph workflow here. The graph workflow documentation is in the Swarms docs, so you could check out how it works and learn everything about the graph workflow swarm there. Yeah. Okay, nice. Back to the presentation. So that's the graph workflow. We hope you like it. We spent a lot of work optimizing it, trying to make it as fast as possible. And yeah, so that's that. And now we have the heavy swarm. And so the heavy swarm, as I mentioned previously, is a implementation of the Grok 4 Heavy from XAI. And so it's basically like a flexible production grade and scalable implementation of Grok 4 Heavy. You could choose any model you want. You don't necessarily need to use Grok, but you could if you want. You could use Gemini, you can use Claude, you could use any model that you wish. And so, yeah. Basically, like how it works is first it decomposes your task into specialized questions and then executes them using 4 specialized agents. So one is a research agent, one is a analysis agent, another one is a alternative solutions agent, and then you have the verification agent. And all these different agents are going to communicate with each other and debate each other to get to the bottom of this task. The results are then synthesized into a conference report by a synthesis agent. So there's 5 or 6 agents total in the heavy swarm. And yeah, we can also showcase a demo of that now. Yeah, so this is how it works. It's super simple. It's like maybe 16 lines of code in total. We can also fix this. We could do another task such as like yeah, so to get started with heavy swarm, first you import heavy swarm from swarm. So from swarms, import heavy swarm. Then you initialize the swarm, heavy swarm. You could also give it a name, say gold ETF research team. You could give it a description. And you give it a list of agents if you want. We already have the agents. You'd also choose the model name. So the model name here is Claude 3 Sonnet, Claude 3.5. Here we can do Claude Sonnet latest, I think. Yeah, I think it's Claude 4 latest. We'll see if it works. And yeah, there's the dashboard feature, which is really cool. You'll see that pretty soon. And then you have the question agent model name as well. So the loops per agent is 1. The more loops per agent that you have, the theoretical, like it's kind of like test time compute. So every loop is like a chain of thought. And within that loop, then the agents will keep looping within itself. So yeah, that's pretty cool. Um, And yeah, you could also define the output type, such as dictionary, string, or you could, in production, you'd most likely use a dictionary, because there's going to be multiple agents outputs. So you could, you can get all the outputs or you can get the final output. Yeah, it's pretty relative. So yeah, these are like some of the parameters that you would use. And yeah, so here we're saying the prompt is, or the task is, find the best three gold ETFs. For each ETF, provide the ticker symbol, full name, price, expense ratio, assets under management, and etc. We could just say like something like, find the best three gold ETFs. Should we do finance or healthcare? Hmm. I want to show you something a little bit cooler. Let me just make a new file. Now specialize this for medical research on finding best treatments for diabetes, or even theoretical treatments. So a common tactic that I use to build agents pretty quick is I use Cursor to help me do some prompting when necessary, vibe prompting, if you will. Identify the best and most promising treatments for diabetes. Yeah, so this is a little bit something more along the lines of why you would use Heavy Swarm. You would want to use Heavy Swarm when you want to solve a very difficult problem, or you wanted to do some complex operation that requires a lot of reasoning. So we are going to run this and you'll see how it works, and it's super cool. So this is the dashboard. We have the configuration. We have some reliability checks. This is the task. Yeah, so there's an issue with the model name. Let's see what the name, Claude model name check. We need to get the right name for Claude 4 Sonnet. So this is what we're going to do. Claude 4 Sonnet. I think this might be the one. Yeah. Yeah. So if you're ever trying to look for a model in Swarms, we support lots of models. It can get hard to find them all, but you could just run a simple 5-line code script to get the model that you want. So we're going to try this, and then we're going to see if it works. All right, so the 4 agents are launching to solve this task. The 4 agents are executing. They're all executing in parallel, by the way. So yeah, we'll be seeing their results shortly. Oh, I forgot to mention, there's a feature here that would allow you to see all the agents' outputs, but there's also a feature that enables you to see only the last agent's outputs. So yeah, you could like basically choose to see, if you want to see just the final agent which creates the report, or if you want to see the worker agents and their processes, then you also can. Agents are still running because Claude 4 Sonnet is pretty big. So yeah. Still waiting. Okay, so now the results are being summarized. Agents completed successfully. Now the agents are running. Still running, still running. It does take some time. So yeah, that's unfortunate. You could actually make this super fast if you use Grok models or Cerebrus models. You don't have to use Cloudforce on it, but if you wanted the best performance, then you definitely can use, Grok 4, or you could use Sonnet 4. And it is finally finished. And this is the entire output of all the agents. So this is the report. So the diabetes landscape has undergone revolutionary transformation, moving from symptom management to comprehensive disease modification with cardiovascular and renal protection. The synthesis of expert analysis reveals a clear shift towards personalized multi-benefit therapies that address not just glucose control, but overall patient outcomes. Key findings: GLP-1 receptor agonists and SGL2 inhibitors represent the most promising therapeutic advances. Automated insulin delivery systems are transferring type 1 diabetes management, combination therapies, and precision medical approaches are emerging as optimal strategies. Cell-based and immunomodulatory therapies offer a potential for disease modification or cures. Technology integration is becoming essential for optimal diabetes management. And there's a very comprehensive report um, of the best potential treatments for diabetes. This is some data on the topic. Pretty soon, you'll also have the feature to integrate advanced research. Advanced research is a implementation of Anthropic's. It is an implementation of Anthropic's deep research system, which we have made a open source implementation of. So pretty soon we're going to integrate this into the heavy swarm so that the agents can do research just as like Anthropic does research. So it can fetch data from the web and etc. So that'll be very, very interesting as well. And yeah, that's an overview of the heavy swarm. You could run it in less than 35 lines of code, most of which is a prompt. It's really less than maybe 15, 20 lines of code. So it's very simple, very customizable, and simple to use. And yeah, that's the heavy swarm. So up next are cron jobs. So a cron job in Swarms is basically like a new structure that can turn any function, including agents, into a scheduled cron job. So, which means that you can schedule these agents to run in particular fashions. So, this class provides functionality to schedule and run. You can run tasks at specified intervals using the schedule library. So here you can see what like it looks like. You build your agent. This is just a basic agent, and here you run the cron job. So in the cron job, you first initialize the agents. You just initialize the agent, and then you have the interval. Here you can see the interval is just a string. So you say like, okay, I want the agents to run every 10 seconds. I want it to run every 30 seconds. Then you can customize that as you wish. And then the cron job, you run the cron job with the task. So you have the task equals whatever string or input that you want. And you can also customize the agent here to do whatever it is that you want. For example, if you wanted it to fetch a new stock and create a report of the stock every 10 seconds, every 2 seconds, then you could do that. And I'll be showing you how to do that now. So yeah, let's get into it. Where is this? There it is. All right, so let's try this. Let's make this easier to look at and also make that simple. Okay, so now we can say, let's reconfigure, create a function. So we're going to analyze the new Figma stock every maybe 5 seconds, 10 seconds. And it's also going to be, I'm also going to show you how to use the tools as well. So yeah. First, to use tools and swarms, you need a function. This function can have any logic that you want. So just put stock. Stop that stuff for now. Then we're going to return a string because agents only understand strings. So yeah, now we have the tool. Now we could add this tool to the agents. Now we could also customize the agents to be a quant agents. And the task should be to analyze a Figma stock ticker Fig. So Cursor's going to do that, and we're also going to clean up our code base now because it's getting kind of messy. All right, now we could run this every 10 seconds or something. Yeah, let's do that. So the cron job is running, and let's try their model. What is the issue here? There seems to be some small issue here, but no need to worry. We can just put it in the prompts. Hmm. What is this issue? Hmm. This is interesting. Let's see if it works first. Too many requests. I've only sent 2 requests. Okay. What we can do is we can make a new file. So we're going to get the price of Solana every 10 seconds with CoinGecko's API. This will be significantly better than using Yahoo Finance because it seems like it is not functional. Yep. So Chris working on that right now. And it seems to be done. All right. So now we could try it again. Current Solana price is $160. That's crazy. It was at $180 the other day. Oh, there's a bug. That's a streaming bug. We gotta fix the streaming bug. Need to fix this bug. So now it's gonna run again every 10 seconds. So we could turn off the streaming and we can make it much better to view. Gonna add that issue soon enough. All right, so this is the first time it ran 160. Solana is positioned significantly above its historical lows, indicating a strong recovery or bullish trends. It's the absence of volume. It's missing some information, but as you see, it's going to run every 10 seconds. We could also make this 1 hour if we wanted to. We can make this maybe every 30 seconds. So, yep, still running. And yeah, so that's a cron job. You could specialize a cron job however you wish. I'm using it to do something I would probably normally do. I'm very curious to see how Figma is doing or Solana is doing. So that's an example of how I would use cron jobs. But the cron job syntax is very simple. As you saw, you basically just give it a task. You give it a task, and then you also say, like, how many times do you want this to run in what interval. So yeah, that's pretty cool. Now I want to take this time to look at some questions or answer some questions. So yeah, okay. We have a question from Mr. Sani. Kai, how do we overcome the context length limitations for generating longer reports? How do we come the context limitation for? Do you mean like the generating tokens? Like you cannot generate X number of tokens, or do you mean like understanding these tokens, input or output? Um, Mr. Sony, if you want to solve this problem, I would probably recommend that you read this paper called Long Agents. We have it in our repository of multi-agent papers here. So if you look up Long Agents, this paper is on scaling language models to 120,000 context length through multi-agent collaboration. So through multi-agent collaboration, you can radically increase the number of tokens that it can process, and you could also significantly expand the max output token. So it's very customizable, and yeah, you should definitely check out this paper if you're interested in processing bigger documents and also summarizing those documents at larger scales. And yeah. Let me see if there's any questions. All right. Now let's continue with the presentation. The streamable HTTP. So MCP has recently changed their MCP architecture. They're currently, I want to say depreciating, but they're currently moving away from SSE support. So, and they're moving into streamable HTTP support. We now support streamable HTTP report supports just natively. There's nothing you need to do on the back end other than just build your MCP servers. And this is how you would integrate MCP into Swarms. You build your server, you give it your URL, and then for whatever agent that you want the tool to use, or whatever agent you want to use that tool, then you would give the MCP URL to the agent. And so this agent now would have this MCP URL. And yeah, that's pretty much it. There's nothing you need to do to be compatible with streamable HTTP. We're also going to be expanding more MCP support. We're going to be adding in multiple MCP server support pretty soon. So you'll be able to provide multiple MCP servers and also execute multiple tools on those MCP servers, which will be very, very powerful. And yeah, so that's that for MCP. Swarm router. So Swarm router got a pretty significant speed up. So for those that don't know what Swarm router is, it's basically a kind of like a simple interface of interacting with all of our most used multi-agent architectures. So you could use sequential workflow, you can use concurrent workflow, you can use hierarchical workflow, you can use any workflow that you like using the router. So, and it works the same ways that other multi-agent architectures work. So you give it a name, you give it a description, you give it a list of agents, you give it a swarm type. And so here, this is sequential. You give it max loops. We're only going to have it, run one time. So, and yeah. So there's nothing really that you need to do to use it. Like the caching happens on the back end. So the Swarm router is being used in lots of cool applications. Like our API is mostly using the Swarm router. So that is entirely powered by the Swarm router. So it's very, very important. And the way that works is it uses a two-tiered caching architecture that dramatically increases the lookup time for the swarm type. So instead of recreating expensive swarm objects for every operation, the swarm router now intelligently really uses previously instantiated swarms when configurations match. And this is significantly much faster than it was before. So yeah, I'll demonstrate an example of this with the hierarchical swarm, because it's the same thing. It's just like a router, and that is now. So let's go over some of the hierarchical swarm improvements. The hierarchical swarm is one of the most used multi-agent architectures that we have, as it's extremely popular because it simulates how humans communicate. In every single company, there's a CEO, there's an executive team, and etc. And so the hierarchical swarm basically tries to simulate this. And so, so we have fixed a lot of issues. We have significantly improved the workflow. The way that it works now is that in the hierarchical swarm, you give it a task, then the boss, the director is going to distribute a number of tasks to worker agents. This worker agents could be doing marketing for you. They could do analyzing. They could analyze stocks for you. There's no like real limit as to what they can do for you. So yeah, it's pretty customizable, and it's very, very powerful if you want to have like a fully autonomous department or like a team that can do things for you autonomously. And it works just as how every other multi-agent system works. So you give it a name if you want, optional, description optional. The agents are required though, so you have to give it a list of agents. You can also choose the number of loops. So max loops equals 2 for, you can increase the number of loops for feedback and more refinements. And then you actually run the swarm with this .run method or parameter. So the .run is like the main entry point for the hierarchical swarm. And now we can showcase an example. Let me find the one that I was using. Oh yeah, so this is the one that I was using earlier. So to start off with, you do from swarms import agent hierarchical swarm all in one line. Pretty simple. You could also specify the full path. So the full path would be this, but we don't need to do that because this is better or more beautiful. So here we're building a list of agents. So, you can put anything in these agents. You can give them tools. You can give it, you can connect them to different providers, platforms, and you can customize them as you wish. They're pretty simple here now, just to illustrate how it works. But yeah, we can make like, all these agents stream. I think there might be like that bug that we saw earlier, but we can definitely try it. And so this swarm is called Sector Investment Advisory Swarm. So or system for sector analysis and optimal allocations. So this is kind of like an investment team or analysis. So here we could change the task to say, let's how we would allocate a $50 billion fund for pharma. Provide specific tickers. And rationale as to why we should allocate to these companies. Provide table of allocations and allocation amounts. So I don't know why it made the function so complicated. And yeah, that's pretty much it. Now we can run this. Let's pull this up so we can see. So this is the director. Now it's calling on the sector analysis agents. So we're going to create a table of suitable stocks and companies to invest in. Recommended allocation. So we're going to allocate LLY. Novo Nordisk is also going to be 18% allocation. And yeah. So now the agents are running. How many loops is this? Is this one loop? Yeah. Okay. One. So all the worker agents are going to run, and then the director is going to run as well. So this is the end of the loop one. So the director can give feedback. So yeah, the director is giving feedback here as well. So if we go to the first one, screening criteria. The sector analysis is advocating for 50 billion plus market cap revenue growth is greater than or equal to 5%, operating margin greater than or equal to 20%, R&D spend as revenue is greater than or equal to 12%. Recommended allocation. LY 22%, 11 billion. Novo Nordisk. Novo Nordisk is at 18%. J&J is at 16%. And these are the allocations. Yeah, so this is how the hierarchical swarm works. Here we could tell the hierarchical director to only call a specific agents. So we could say only call this sector analysis agents. Only call the nobody else. You see? So it can call only the sector financial analysis. So it doesn't have to call agents that are not really relevant to the task at hand. And there you go. That's pretty much it. Um, Here in this one, it's saying Pfizer 18, Johnson 16, Eli Lilly 14, Merck 12. Is Novo here? Only 7. Wow. And now the director will give feedback. So the allocation plan is well structured, yada yada. Feedback, expertise, and risk management. As a risk management analysis, your insights into the potential risks associated with the pharmaceutical sector are crucial. The analysis lacks detailed risk assessment for each company. It would be beneficial to highlight specific risks, regulatory market competition, and how they might impact the investment. If we run it again, if we add 2 loops, you can clearly see that the agents will improve over time. So we're going to add 2 loops, which is here. And then we can see. There you go. It talks about the risks, such as the first agent has mentioned. The rationality. And yeah, that's how the hierarchical swarm works now. We're going to be making it much more comprehensive by enabling the agents to choose who they want to talk to or who they need to talk to and things of that nature. So a lot of improvements are coming to the hierarchical swarm as well. And now moving on, bug fixes. Over the past few weeks, we have eliminated a vast array of critical bugs to enhance the stability, performance, and reliability of swarms. The fixes mostly address issues in conversation handling, workflow functionality, agent operations, vision processing, and much, much more. So we fixed a lot of bugs in processing vision, base64 handling, and things of that nature. If you want to see the latest issues that have been fixed, you can go to our GitHub and you could check out to see some of the closed issues here, such as this issue. We also added a documentation with Azure OpenAI, which is pretty popular. We also fixed this conversation.saves JSON issue, which does not work with save enabled because save enabled is a redundant parameter. And if you want to learn more about it, you could, go there and check it out. And yeah, that's you could check to see all the issues that were closed over the past 3 weeks. And yeah, so one pretty big type of renovations that we're doing within the Swarms framework is that we're trying to radically increase the number of contributors that we have. And we do this by providing a very clear and simple governance framework for people to contribute to Swarms. And Swarm improvement proposals, or we call them SIPs, are an easy way to propose new changes and new features to Swarms. And so we thought about doing SIPs because we wanted to lower the barrier to entry for new contributors that wanted to contribute to Swarms. So SIPs will mostly be used for introducing, I would say, medium to large architectural improvements to Swarms and new features, while ensuring proper community review and consensus. This framework enables transparent collaboration and maintains high standards for the evolution of the framework. So SIPs are designed for substantial changes, including new agent architectures and coordination patterns, core framework modifications and API enhancements, integrations with new LLMs and external services, breaking changes requiring backward compatibility considerations, and complex multi-component features. If you wanted to learn more about the SIPs, we have a documentation about it on our docs. So if you go to our docs.swarms.world, you can basically go here and check it out on these SIPs. So it's right here, protocol SIPs, and you can see all the documentation relating to SIPs. The next slide is a template. So, SIP, whatever the name of the feature is, you give it your name, the type, status, proposal, created, when was it created, abstracts, just 200-word summary, motivation, what is this, how is this beneficial to our users. You could, specify in greater detail, class, function, etc. How do you want to implement this, any alternatives, and reference implementation. And so, yeah, you would basically submit a PR for this. And then once the SIP is, if the SIP is agreed upon by the community, then we can simply approve the PR for this contribution. And so I'd say, like, for now and in the foreseeable future, our mission is to get more and more contributors to Swarms. And this is a good solution for that. And that's pretty much it on the latest updates. Thank you for joining the workshop. Thank you for listening to me talk about all this new agent stuff. And so thanks for joining. We're going to be doing these like every single time there's a new framework update. So we're going to try and do 2-week sprints from now on. So there'll be a new Swarms framework updates, new pip package updates every 2 weeks. And every single one of those 2 weeks we'll be doing a workshop like this where we show all the new updates and we also go over the code and demonstrations in real time. And I'll check any questions. Does anyone have any questions? Janan, how do cron jobs make things easier in the framework? So what cron jobs do is they basically enable you to like the cron jobs enable you to schedule things that happen in frequent intervals. So you can have an agent run every 20 seconds, 30 seconds, every 10 minutes, every hour. And then this agent will just always be running for that time period. So cron jobs are very important if you want to like deploy your agents and make sure they're always running, always running. DNet says, are you streaming somewhere else? Yeah, we're streaming on Twitter as well. So we're streaming on YouTube, Twitter, and also our Discord. If you want to join our Discord, I'd recommend you join. You go to the swarms.ai website and you click the link there. Yeah. All right. Does anybody have any questions? Yeah, all in all, this update was very, very impactful. Like this is one of our best updates ever. Just like the sheer combination of like all the new functionality that we have and how good it is really cannot be stated in words. You just have to like build with yourself and try it out and see like how it actually works in real life. Yeah, but definitely one of our best updates ever. And there'll be a new update in 2 weeks. which is very exciting. I'm very excited about this one. In the next update, we're going to be introducing simulations, which are going to be very fun. Um, we've been wanting to do simulations for a long time, but simulations are going to be very big. They're going to be like 100 plus agents minimum. So yeah, that's going to be pretty crazy. That's going to be pretty cool. Yeah. If you enjoyed this workshop, please check out the GitHub. Please start fork and share the GitHub and contribute to it if you're a developer and you're interested in agents. It means a lot to us, and you can support us a lot. So yeah, that would be very helpful. And yeah, check out our website, join our Discord down below. Go to Swarms.ai and you can get the Discord link if you want to stay in touch with the community. It's the best way to stay in contact with the Swarms team, including myself. I'm always on the Discord. So I would recommend anyone to join the Discord. Yeah. And yeah, I think that's pretty much it. Let me just share this screen. And yeah, again, thank you for joining the workshop for the Swarms 8.0.0 release. This was a fantastic development cycle, and we're looking forward to introducing some more bleeding edge agentic infrastructure and all new features in the next cycle. So every cycle is 2 weeks. So you'll be seeing a new cycle from us in 2 weeks, or a new update from us in 2 weeks. So yeah, definitely stay in touch, and check out our website, join the Discord, go to the marketplace, share your agents in the marketplace. We haven't really done a technical workshop for the marketplace, but I think we could do that. Yeah. Definitely follow us on Twitter, and yeah, thank you for joining, and yeah, being here with me. Um, and yeah, thank you, everyone. Have a good day. Have a good weekend, and talk soon. Yeah. Bye bye.